Hey, welcome back. So this whole section has been about iterators, and it's still about iterators, but more specifically, we're talking about generators. So generators are iterators. They're a subset of iterators. Every generator is an iterator, but not every iterator is a generator. So what are they? Well, they're basically a quick and easy, a short way of creating iterators. And they can be created in two ways. The first is with generator functions, which use the yield keyword. We'll come back to that. And the second is by using generator expressions, which you may recall we talked about very briefly in the built-in functions section of this course. But let's start by talking about generator functions. Okay, so generator functions are just a regular old function, except instead of using the return word keyword, we're using the yield keyword. And instead of returning once, a generator function can return more than once, or yield more than once. And then finally, when we call a regular function, it returns a return value. When we call a generator function, it returns a generator. So a generator function is just like, it's a way of creating a generator, which is an iterator. It's very complicated and confusing when you're explaining it, or when I'm explaining it like this. Let's look at an example. So here is our first generator function, which returns a generator. So I'm just going to copy this and actually go to a terminal, open it up, and paste it in. Okay, so it's called count up to, def count up to max. And notice this is just a regular function syntax. We start with count equal to 1. Basically every time through, we check is count less than or equal to max. If it is, yield count. So what yield will do is it will return the value of count and then pause, and it will stay that way until next is called on count up to. So it's an iterator. So every time we call next, when it hits yield, it returns the value of count and it stops right here. It doesn't even go to this line, it stops right here. But then next time it resumes, then it adds one to count, then it goes back around, does the while loop again, yields count, and then next time through adds one, and so on. So to use it, if we just call count up to 5, for example, there we go, it's going to return to me a generator object. So that's the special magic in Python. If you write a function and you put yield in it, anywhere instead of return, it's going to give you a generator object. So this itself is not a generator. This is a generator. It's a generator function. It creates a generator for us when we execute it. Okay, so now if I save that to a variable, let's just call it let's call it counter equals count up to 5. Once again, I reference counter. I can't execute it like this. It's not callable. What I do is I call next on counter. And it gives me 1, first time through. Next gives me 2, and then 3. What's happening here is that it is keeping track of its state. So unlike a regular function, you run it once and you run it again, the same thing happens. It doesn't remember what happened last time. This is different. Each time through, when we call next, it doesn't store everything in the past. So it never has all of the data in memory at once. 1, 2, 3, 4, 5, 6, or whatever the numbers are here. But it keeps the most recent one, it yields and stops. And then next time through, it discards that and adds 1, and then it keeps that. And next time through, it adds 1 and keeps that. So it only knows one thing at a time. But it's storing one thing at a time. Every time we call next, it just gives us the next thing. Until we keep going and we get that stop iteration. So we could easily write our own iterator, which we've already done it, actually the counter iterator in 2 videos ago, where we had the class counter. Where are you? Here? Yep. This does basically the same thing, except we can specify a low and a high. In my example here, we're specifying a high, and that's it. But instead of creating a class, instead of setting up a init and all of that, we can do the same thing with a generator function, which returns a generator object. The generator object automatically has next added to it. So if we looked at counter, actually, let's just do help counter. You can see it has next. dunder next, and dunder iter already set up. So we don't have to do that. So this is a really easy way of creating an iterator. But remember, we don't have all of the data at once. We get it one thing at a time. We can loop through it. So let me make a new counter, count up to 10. And we can loop through it for num in counter, print num. And we get 1 through 10. If I did the same thing, but I called next on counter once, and then I do my for loop, we get 2 through 10. When we create the generator, we start off count, or whatever, what was the variable called? I already forgot. Yeah, count set to 1. And that's the only thing that it yields to us. Next time through, it yields 2. So there's no going back. Once we called next the first time here, counter is set to 1. And so next time through, it goes to 2. So we can't go back to the beginning, and we can reinitialize a new instance of that generator, but otherwise we've gone through it. And so it just goes to the end. So every time next is called, it moves forward one space. And of course, as we've already seen, in a for loop, it automatically calls next. So it's going to call next on counter over and over and over, and then it's going to handle that error. Because remember, if we call next on counter, once it's exhausted, we get the stop iteration error, but the for loop automatically catches that and just breaks the loop instead of giving us this. Okay, so just to reiterate all of this, very funny called. What we have, a generator is returned from a generator function. So it's just a way of making an iterator quickly. We never have to determine what happens when we call next. We don't have to, we don't define next. We don't define iter. We never are raising the stop iteration error. We don't have to do any of that like we did over here. Instead, we just define a function, call it whatever you want. And in our case, we're just doing a counter, but we could do squares, we could do prime numbers. We're not limited just to working with numbers, by the way, but we could do any sort of sequence or series of numbers or data, as long as we could call next over and over in a logical pattern. So we don't have to do any of that, though. All we define is some code that should run and yield. And wherever that yield is, it's going to stop immediately, return the value that we specify, stop execution, and just wait, sit there running in place. Running is the wrong term because it's not actually doing anything. It's just sitting there. And it takes up way, way, way less memory than if we did the entire thing as a list, which we absolutely could do. Counter equals count up to 10. If I did list of counter, it goes through every item and adds it to a list and gives it to us. So if we need all the values at once, we have access to them. But if we're only using each value one at a time to do something, we don't have to turn it into a list. And that's where this kind of ties into generator expressions, which we haven't talked about yet. We will in 2 videos from now. But if you remember, back when we talked about sum, the built-in function sum, I mentioned you don't always have to pass in a list of data. If you don't need that list anywhere else, you can pass in a generator expression. And it's just easier. It takes up less memory. It's faster. Okay, so we'll get there. I'm kind of jumping ahead there. Generator function returns a generator. A generator is an iterator. It's a quick and easy way. I hope that made sense. It's kind of something I'm scared about in this video. It's just difficult, kind of weird stuff. Okay, leave some feedback and comments if you have questions. See you in the next video. We're going to define another type of generator that is an infinite generator.